Hi everyone, we are Crisis Averted and we're the Emergency Services Institute team from NC State. My name is Lee Atchison and I have a biomaterials concentration. This is my team member, Steve Koslick, biomechanics concentration. My other team member, Sarah Hennis, also biomechanics concentration, and Phil Koslick, biomechanics concentration. We are here today to tell you about our product, the Thrombo Pro, which addresses many of the key issues with a serious condition known as stroke. How many of you have known someone who suffered from a stroke? A lot of you. This doesn't surprise me, but what did surprise us was knowing that a stroke can occur to someone as young as us. When we first went to Wake Med, we were given a case study of a patient who was 24 years old and a basketball player who suffered a major stroke. He was forced to undergo the most common treatment for stroke with a mechanical clot retrieval device. Unfortunately, these devices are ineffective, they're inefficient, and they cause serious physical disabilities after the treatment, even if the patient survives. So for this basketball player, that meant never making a jump shot ever again. Imagine at 24, never being able to pursue your dreams ever again. This is our motivation for addressing the stroke.
So after learning about our patient, we decided to do a little bit more research to figure out what exactly is stroke. We discovered that there are 700,000 cases each year for stroke, as well as it's the second leading cause of death in the United States. Out of all of these cases, 85% are caused by ischemic stroke. Ischemic stroke is basically caused by a clot in one of the blood vessels of the brain. And we also learned that, based on talking to doctors, that the quicker that a doctor can access that clot and either remove it or restore blood flow, it significantly reduces the effect of that a patient will have for stroke.
So as we shadowed at Wake Med and Duke, two common procedures were done in order to eliminate blood clots which cause strokes. The first was the use of a drug known as TPA, and TPA is basically an anticoagulant, so it helps to dissolve the clot. And one problem we saw with this was the prevalence of TPA, and a lot of times the TPA had a tendency to travel in other blood vessels and cause excessive bleeding and hemorrhaging in some of the other organs of the body and in the brain. And the second way they removed blood clots was through mechanical catheters. And basically, a surgeon would control this catheter, insert it into the blood vessel, traverse it to the site of the clot, where he would then attach it to the blood clot and pull out the blood clot. And one problem we saw with this was when the surgeons were pulling on the catheters, there was a tendency for the blood vessels to migrate in the body, and in some cases, blood vessels rupturing and causing more damage to the patient. So there really was no efficient method of removing a blood clot that was local to the blood clot.
And what you see on your screen and what we designed and built was a catheter and base, and it's a four lumen catheter. The top and the bottom holes, right here and here, are controlled balloon inflation and deflation. Left and right holes run along the length of the catheter, and they control the infusion of the drug. And we're going to illustrate this. We're going to show you a video we put together. And so this device can be used. The user of this device can control syringes on the outside of the body. It can traverse the length of the clot, and once it gets through, either punctures or moves around this sophisticated blood clot, the balloons can then inflate both proximally and distally to the clot. And once both balloons inflate, you effectively isolate the blood clot, and the drug can be inserted into another channel to dissolve the clot.
So moving forward, especially with our business plan, we would want to acquire the appropriate funds so that we can create a small-scale model of our device. We will continue to test it and create improvements based on that testing. And a few things that we would want to include is catheter flexibility. We want to make sure that our catheter can navigate all the way up into the brain and reach the clot site. The blood vessels in the brain are very small, and they have a lot of really tight twists and turns. And the other thing that we want to include is having a dual flow system, so that way that as we inject the drug at the clot site, we can also suck out excess drug and clot material that's been dissolved. We want to thank our mentors at Duke, Wake Med, and at NC State. And if you have any questions, you can either visit our website or come see us at our poster session.
Wow.